The text goes as followed. Formulate and test conjectures about the properties of parallel and perpendicular lines based on explorations in concrete models. Formulate and test conjectures about the properties and attributes of polygons and their component parts based on explorations and concrete models. Use constructions to explore attributes of geometric figures and to make conjectures about geometric relationships. The objective is the students will find the difference between medians, altitudes, and perpendicular bisectors and solve the equation. Okay, class, my name is Miss Molina, and we're going to be talking about medians, altitudes, and perpendicular bisectors. Right now, I'd like you guys to take out a sheet of paper, and I want you to write in your own words what you believe to be the definition of median, altitude, and perpendicular bisector. Okay, class, now that you all have written down what you believe to be the definition of perpendicular bisectors, medians, and altitudes, we're going to go through this PowerPoint. It's very interactive, so I want you all to be writing down notes because I'm going to be calling you all to be answering some questions. Here we have the goal, which is to find the difference between medians, altitudes, and perpendicular bisectors. It says here, just as there are special names for special types of triangles, so there are special names for special line segments within triangles. Now, isn't that kind of special? Now, for vocabulary, we're going to freshen up on vertex. It's the common endpoint of two rays or segments. So here you have your vertex, and your vertex here. So this is a little illustration of what a vertex is. Now, for the midpoint, it says the midpoint of a segment is the point that divides a segment into two congruent segments. If you have a midpoint, then the segments on both sides are congruent. That is why you will see the tick marks here, showing that this side is congruent to this side, and this being the midpoint. It says hint, for the measure of the entire line, add both sides. So if you want to measure from here to here, you'll just add this plus this. Now we're going to jump into medians. Now looking at this picture, we have our vertex and our midpoint, and this being our median. Both sides are congruent. This is our median. It connects from the vertex to the midpoint. So that's very important to remember. Medians is when it connects from the vertex to the midpoint. Vertex to midpoint. So now I want you guys to continue taking notes. We're going to continue on. So this is very interactive. We're going to have what is NC, here, NC, if NP is 18. This being our median, what would this be and this be? Very good, class. It is 9. So now if DP, right here, is 7.5, what would NP be? NP be? Very good, 15. So now what is ED, right here, ED, if DC is 14? So if you are given what DC is, what would ED be? It would be the same thing because this is the median, showing that this side and this side are congruent. So it would be 14 and 14. And what is AC if BC is 9? It would be 18 because it's double. Now we have some discussion questions. I want you all to right now write these down and to answer them and work in groups of 2 and 3 to discuss these questions. Okay, now that you all have discussed between yourselves and have shared a few of your answers with the class, we're going to continue on with the PowerPoint. So now we have our triangle A, B, and C. If CE, which is this line here, and AD are both medians, now we have an equation of CD equaling TX plus 5 and BD equaling 4x minus 1 and AE equaling 5x minus 2. Now we have to find BE. And the previous examples we were working with just simple numbers. Now we have equations. So we're going to have to solve for x. So we have that BD is equal to CD. So we can set these equations equal to each other. Showing here. Now we're going to solve for x. We end up finding out that x equals 3. Now that AE equals BE, we're going to set that BE equals our 5x minus 2. Plug back in the x of the 3, and then we get BE equals 13. So do you all have any questions on how to transition from just regular numbers to now plugging in the equation? If not, we're going to continue on. We have BE equaling 13. Before I go on, how many medians do you think a triangle has? Okay, we got 3, 5, okay. It actually has 3. So you were right, it was 3, very good. It has 3 medians. Concurrent, it says when 3 or more lines or segments meet at the same point. So we have our 3 medians, and they all meet at a single point. The intersection of the medians is called the centroid. So when these 3 medians meet at this point, it is called a centroid. Important fact, distance from vertex to centroid, not vertex to median, vertex to centroid, is twice the distance from centroid to midpoint. So from vertex to centroid is twice the distance from the centroid to the midpoint. So showing here is showing that 2x, x. Why 2x? Because it's 2 times this part. Vertex to centroid is longer, centroid to midpoint is shorter. So make sure that you guys are writing these notes down because this is very important. So we have our equation x plus 2x is going to equal the whole median. How much is cx? If we have the xf is 13, how much is cx? What is cx? It's twice this. So what is 2 times 13? It is 26. Very good, guys. Good job. How much is xd? So this is the longer part than this one. So it's going to end up being half of this one. So xd equals to 9. So now in our triangle here, now we're going to find an. Can you guys work on this for a couple minutes? I want you guys to answer this on your own, and then we're going to share what you guys got. Okay, thank you, Charlie, for volunteering and showing us how we find an. Now we're just going to go through the process quickly because you've already gone through it. AE equals 2 times 12, which is 24. So then we end up solving for AN, which AN equals 36. Thank you again. We're going to continue on. Now, do you all have any questions? I want you guys to learn this vocabulary. It's very important. We've gone over already vertex, median, centroid, and we're going to continue on. Now we're going on to altitude. Let's look at this picture for a second. Okay, vertex to the opposite side and perpendicular. Okay, so that's the difference between what we went over first, and now altitude, it's creating a perpendicular line. So if I'm standing here straight, what angle am I making with the floor? That's right, yes. I am making a right angle, which is perpendicular. I am perpendicular to the floor. The altitude is the true height of the triangle. It is the true height. That is very important. I want you guys to write that down. Tell whether each red segment is an altitude of the triangle. Okay, this one is not. Why is it not? Yes, very good. It's not because it is not creating a perpendicular bisector here. This one is, and this one also is. This one is very important because it is on the outside of the triangle. You can still have the altitude. If it's like this, you just create the showing the true height and creating a perpendicular. You're creating a 90-degree angle here. The altitude is the true height of the triangle. So now this is just some examples of showing the altitude here with these different triangles here. So you guys take a second to look at that. Now we have perpendicular bisector. So here in the picture, midpoint and perpendicular. So it does not have to be from here. It's as long as it's bisecting, creating a 90-degree angle, which is showing it's perpendicular, and bisecting. Bisecting means it's separating these into 2 congruent pieces. So it shows both sides are congruent. Make sure you see this or it is not a perpendicular bisector, okay? So now we're going to tell whether each red segment is a perpendicular bisector of the triangle. So we have that this one is not because it does not have the tick marks showing that both of these sides are congruent. This one also is not because it is not bisecting this line. Now this one definitely is. It's creating a 90-degree angle perpendicular to this line, and it has a tick mark showing that this side is congruent to this side. So now that we went over perpendicular bisector, altitude, and medians, I want you guys to write now in your own words what you know is the definition of perpendicular bisector, altitude, and median, and comparing the three. That is the end of the PowerPoint, and I want you guys to do that right now. Okay, class, so to finish off the lesson, I want you guys to get into groups of 2 and 3 and to discuss where in the real world would you see a median, altitude, or perpendicular bisector. Then I'm going to have volunteers from each group to come up and share with the class what real world examples they have seen, and then we're going to close off with just summarizing what we've learned.